Hi everyone, this is the second lecture on Unit 2 of Functions Rate of Change. Today we're doing Lesson 2.2, Estimating Instantaneous Rates of Change from Table Values and Equations. Instantaneous rate of change is the exact change of a function at a specific variable x equals to a. The value a is estimated by values of average rates of change for small intervals of x values around a. Instantaneous rate of change is calculated by the average of two average rate of change close by. There are two methods to calculate instantaneous rate of change. One way is to find the average between two intervals. The other method is to find the average between two y values near the value of a. Let's look at example 1 from your learning resources. Using average of two intervals, that's the first method. Here we're representing the equation of f of x equals to 3x over 2 plus 1. And we're asked to find the rate of change at point x equals to 2. The first step we have to do is find the average rate between 2 and 1.5. That would be f of x equals to f of x of 2 minus f of 1.5 divided by the time elapsed, which would be 2 minus 1.5. That would give us 0.75 over 0.5. And the final answer of 3 over 2. Second step is find the average rate between 2.5 and 2. That would be g of x equals to g of x when x is equal to 2.5 minus g of x when x is equal to 2 divided by the time elapsed, which would be 2.5 minus 2. That would give us 0.75 over 0.5 and the final answer of 3 over 2. The third step is to find the average of two average rate of change, and that would be the instantaneous rate of change. What we do is h of x equals to f of x, which is the one that we calculated in step 1, plus g of x, the answer that we calculated in step 2, over 2. That would be 3 over 2. Thus, the instantaneous change is 3 over 2. As a side note, not in all cases, the instantaneous rate is the same as the average rate. Now let's look at example 2 from your learning resources using the nearby average rates of change. That's the second method in determining the instantaneous rate of change. So here we're given the equation pt equals to 500 times 2 to the power of t. We're asked to find the instantaneous rate of change at t equals 2, having 2 as the midpoint. First, we write the equation out like we always have. That would be px equals to p of x when x is equal to 1 minus px when x is equal to 3 divided by the time elapsed. That would be 1 minus 3. That would give us 1,000 minus 4,000 divided by negative 2. The two negatives cancel out and we will have the final answer of 1,500. $1,500 is the rough estimate of the instantaneous rate at t equals to 2. However, if you want a more precise number, then you need a smaller interval. This method is referred to as the squeeze theorem. Now let's use a smaller interval of 1.5 less or equal to x less or equal to 2.5. We do the same as the above question. P of x equals to p of x when x is equal to 1.5 minus p of x when x is equal to 2.5 divided by the time elapsed, which would be 1.5 minus 2.5. That would give us the answer of 1414. And 1,414 would be a more precise estimate of the instantaneous rate at t is equal to 2. This is the end of this lecture. Remember to do your practice questions and your assignments, as well as check out the activities. Upload them for your teachers to mark, and I'll see you guys next lesson.